not record. Sorry, I did not record this one. Okay. So the L1 regularization is called your lasso, and L2 regularization is called ridge regression. And the combination of these two are called your elastic net. Okay. The elastic net can address both the collinearity and it does the feature selection. Whereas in the case of the lasso regression, it does the feature selection, but it is not addressing the multicollinearity. Whereas in the case of L2 regularization technique called reach, in the case of reach regression, it addresses the multicollinearity, but it is not doing the feature selection. Okay, so both of them has its own flaws. To overcome that, they came up with something called elastic net. Supposing you don't have any, let's say all the features in your data set are statistically significant. Statistically significant abdinale, you should think that all the variables are helpful in predicting the outcome variable. All the features are helpful in predicting the outcome variable. Okay, so that means statistically significant. But in that case, if you have collinearity, then simply you can go for ridge regression. When to use ridge regression? In that kind of situation, you can go for ridge regression. Supposing I have L1, so let's I have all the variables are, so I have a mix of both statistically significant, non-statistically significant features in my model, but we don't see any collinearity. In that case, you can go for lasso. Got it? This is how you should be able to answer it smartly. They'll ask you the tricky question like this. L1 regularization is your lasso and L2 regularization is your ridge regression. Okay. So if you don't, let's all the features are statistically significant, then you don't have to do feature selection. Then you can, but it has collinearity, then you can go for ridge regression. Okay. But whereas in the case of lasso regression, you have a mix of both statistically significant and non-statistically significant features in it, but you don't have collinearity. This is very rare here. So this is very rare situation. Collinearity will be there, okay, but you don't have collinearity. So in that case, you can go for lasso. Because lasso cannot address the collinearity. Since you don't have the collinearity, then simply you can go for lasso to do the feature selection. Lasso is for feature selection, but it doesn't address the collinearity. Whereas reach address the collinearity, but it is not doing the feature selection. And the last one is elastic net. It is an hybrid of both L1 and L2. So if they ask you when to use L1, when to use L2, okay, you can tell this way, okay. But though elastic net is an hybrid of this one, right? When you fit the model, you will see that elastic net will not reduce the error. Sometimes you might find the ridge regression will do with ridge regression, your model accuracy is good, okay? Or sometimes the lasso regression, right? The performance will be good with that model, okay? But we will have to compare all the models. Fit a linear regression model, fit a lasso regression, ridge regression, and elastic net. By compare all the different algorithms, okay, what is my model accuracy? Which model has lesser root mean squared error? The lasso or ridge or elastic net or linear regression? Of all the four, which one is better? See, this technique no one taught us. Okay, so you know what? Once you get into a job,